So type 3 with these trig substitutions are going to be tan-secant combos, kind of like what I've been doing with the sine and cosine. Okay, these are a little more challenging as there are only two good options for your du because it has to do with the derivatives, right? So one option for a du is secant squared x dx because my u would be tangent. You know the derivative of tangent is secant squared. The other option for your du is secant tangent. And that's because if I let u equal secant, the derivative of secant is secant tangent. So these are the only options. So you will never make a du equal to secant x dx. Never. And you will never let du equal tangent of x dx. Never. You're going to let du equal secant squared or du equals secant or tangent secant. Okay, so you want to leave even powers. So when you're looking at an integral, you'll want to say, do I want to pull off two secants or do I want to pull off a secant and a tangent? And the identity that you'll want to use is this. So I always remember this. Tangent's got the tall guy, the plus has got the tall guy, the one's got the tall guy. So these all have sticks on this side and this doesn't. So you just got to get this memorized. However, because you're not always going to have your little notes beside you. So leaving even powers, using this identity in these two specific du's. All right, let's look at this. So here I have a cube and a cube. They're both odd powers. I want to leave even powers, so that's why I'm going to peel off a secant and a tangent. So that gives me a tangent squared and a secant squared. And so this is my du. If that's my du, my u must be secant because I know the derivative of secant is secant tangent. This is the identity. So I'm looking at this u is secant. What will be taken care of? This will be taken care of. This will be my du. So I need to rewrite tangent squared in terms of secants. Rewrite tangent squared in terms of secants. Okay, so I've written the same thing down here. So this here is this, right? All x's. I'm going to take out tangent squared, and I'm going to put in secant squared x minus 1. And then carry everything else along. Secant squared, secant tangent. Okay, now it's time to put the u's in. So u is secant, so there's secant squared minus 1. Here's another u squared. And then all of this is du. Multiply this out, and then take the antiderivative by increasing the exponent, and then putting the x's back in, the secant of x in for the u. All right, so this one here, secant to the 6th, tangent to the 4th. All right, I see even powers. So I'm thinking that I want to take a secant squared off because I want to leave even powers. So I'm going to take this secant to the 6th and break it into secant to the 4th, secant squared. And this guy just carries along for the ride. So let's see, but that's my du. My u's got to be tangent. If that's my du, u has to be tangent because I know the derivative of a tangent is secant squared. So to make this u substitution work, that would be taken care of with u to the 4th. This would be taken care of with du. I would need to change this to tangents. Okay, I need to go slow here and rewrite this and think of this as secant squared squared because this identity has nothing to do with to the 4th power, right? So squared squared, so that putting in for secant squared, tangent squared plus 1 inside the square. And then I've got it all set up for ready to go for u substitution. So I put u in for tangent, so I get u squared plus 1, all squared. This is tangent to the 4th, and this is du. So be careful that you're not doing bad math. So this squared, I get this squared, this times 2, the middle term, and then this squared gives me this. and then u to the 4th carrying along. And again, I've got to multiply this out. You add exponents, right? U to the 4th times u to the 4th gives me u to the 8th. Add the exponents here, 2u to the 6th, and then u to the 4th. So finally, I'm ready to add 1 to the exponents, right? And then put the x's back in. Phew, all right. This integral here is going to come up quite often. I know I put it on your homework in Math 150 often enough. I just want to remind you, this doesn't need any technique. You just need to use the identity because you know the antiderivative of secant squared is tangent, and you know the antiderivative of 1 is x. So this is going to come up, so don't forget.